so let's take a look at this question here. We're going to approximate each of the following to the nearest tenth. Okay, that seems a little odd. Alright, what is the square root of 1? That should be equal to 1, and the reason for that is 1 times 1 is equal to 1. The definition of a square root is a number when multiplied by itself will equal this number, the number inside the radical known as the radicand. What is the square root of 4? Well, that should be 2, because 2 times 2 is equal to 4, the number inside the radical. 3 times 3 is 9, so the square root of 9 is 3. 4 times 4 is equal to 16, so the square root of 16 is equal to 4. I don't know this one off the top of my head. We'll have to come back to that. The square root of 25 should be 5, because 5 times 5 is equal to 25. Alright, so that brings us to this, 5. That brings us to the unusual one, which is the square root of 20. Now, while we don't know for sure what its value is, we know it should be between 4 and 5. Why does that make sense? Well, the square root of 16 is 4, which should be less than the square root of 20, which should be less than the square root of 25, which is 5. So based on this idea, the square root of 20 has to be somewhere between 4 and 5. And since 20 is a little bit closer to 16, it's probably closer to 4 than it is 5. So if I were to guess, I would say it's about 4.4. I could be wrong, but let's find out. 4.4 times 4.4 is equal to 19.36. That's pretty close. Let's take a look at 4.5. 4.5 times 4.5 is 20.25. Let me do 4.4 again. I want to keep them on the screen at the same time to compare. Which of these is closer? I suppose 4.5 is closer, so a better approximation would be about 4.5 in this particular case. Alright, that's obviously not the exact value, because as we can see, neither of those are equal to 20. I mean, we can get closer. It should be a little bit smaller than this, maybe 4.48 times 4.48. That's closer. Or we can just use the calculator's feature to calculate it. It's here above the squaring button. The square root of 20 is equal to 4.47 approximately, or closer to 4.5. Alright, so it's not a whole number. That's why this is an approximation. It's not an exact value. It's a rounded value. Okay, even the calculator has a rounded value. Alright, so let's move on. And the reason these are much easier, these are known as perfect squares. And perfect squares are numbers which can be calculated by squaring a whole number. So 1's a perfect square, 4's a perfect square, 9's a perfect square, 16 and 25 are all perfect squares. 20 is not. Let's move on. Before we do anything, you should memorize a list of the first 15 squares. They're not that hard to get. You could just square the first 15 numbers. So that's 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. These are the ones that are harder to remember. Most people know this one, because it's on their multiplication table in their composition notebooks. This is 121. This is 169, and this one is 196. Those are easy to remember because they're opposites of one another, at least those two positions, and that's 225. It'll be important to know these perfect squares. So all the red numbers here are perfect squares, whereas all of these numbers are just integers or whole numbers. Alright, so any other number not on this list, like 3 is not a perfect square, 8 is not a perfect square, 20, 30, 50, 75, all of those are not perfect squares. Alright, so let's take a look at what a radical is. or the parts of a radical. The number in front of the radical is known as the coefficient, which just really means a multiple. I wrote that incorrectly, I apologize. A multiple of a variable or a radical expression, so it's a multiple. So there are 5 radical 80s. The number inside of the radical is known as the radicand. All right. So let's approximate each of these. So this is 5 times what value? What is radical 80? Well, based on what we did before, radical 80 is close. It's a little less than radical 81, which is 9. And the next radical is radical 64, which is 8. So it should be something like 8.9. Let's use a calculator. It is 8.9, so we'll go with that. 8.9. And that is approximately equal to, so hold on, we got 8.9. Whoops, didn't mean to do that. 8.9 times 5, which is 44.5. Radical 20, as we said, was about 4.5, so that's 10 times 4.5, which is 45. Radical 5 is somewhere between radical, it's between radical 4 and radical 9, so it's between 2 and 3. Very close to 2, so I would guess 2.2. See what the calculator says. About 2.2, yeah. So that's 20 times 2.2, which is 44. So if you might have noticed that all of these values are approximately the same, and that's because just like there are equivalent fractions, these are actually all equivalent radicals. Now, because we approximated these values, you'll notice that there is some room for error, but these are actually all the same, and we're going to see how in a moment why all of these are the same. Okay. And just like fractions, radicals have a simplest form as well. A radical is in its simplest form when the radicand has no perfect square factors. So 80 has a perfect square factor of 4. 4 goes into 80. 16 also goes into 80. 20 has a perfect square factor of 4. So it's not in simplest radical form. 5 only has a perfect square factor of 1, which we kind of exclude from this definition. Matter of fact, we can even write that in ourselves if we want. So let's say other than 1. Other than 1. Reason being is if you simplify out a 1, it does not help. Alright, so let's look at how to simplify a radical. We'll look at how to go from here to here, and then from here to there. Alright, so we know 4 is a perfect square factor of 80, so 5 times radical 4, that's 5 times radical 4 times radical 20. Two radicals together, or multiplied together, equal its product. So radical 80 does simplify to become radical 4 times radical 20. That's 5 times the square root of 4, which is 2, times radical 20. And that's 10 radical 20, which you'll notice is what we got here. Okay? We can simplify that further, because radical 20 is radical 4 times radical 5, and this is a good indicator that we're almost finished, because this is what we're going to get. So that's 10 times 2 radical 5, which is 20 radical 5. So this is in its simplest radical form. Now we could do this a little faster. I'll show you how to do it a little faster. We could simplify this straight to 20 radical 5, and we do that by finding the largest perfect square factor that goes into 80, in this case, which is 16. So this is 5 times the square root of 16 times radical 5. That's 5 times 4 radical 5. which is 20 radical 5. So the larger the perfect square you factor out, the faster this is. If you don't do it in one shot, it just means you have to do it twice, which isn't, or maybe even 3 times, but that doesn't mean you can't do it. Alright, so let's take a look at a couple more examples. A couple more things to know. We're going to simplify these based on what we just saw. Radical 3 times radical 3 is radical 9, which is 3. 2 radical 3 times 5 radical 3. Based on what we saw in the previous video, we can rearrange these to be 2 times 5 times radical 3 times radical 3. So that is 10 radical 9, which is 10 times 3, which is 30. Alright, this is the commutative property of multiplication. We can reorder terms that are being multiplied as long as their signs stay the same. These were all positive, so these are still positive. Same thing here. But based on what you might have noticed, we just multiply the coefficients. So 2 times 5 gave us the 10. The 3 times 3 gave us the 9. That's why this is written here as a rule, but it's based on what we've already noticed. So if we multiply these, we get 48 radical 50. Now 50 can be simplified, so that's 48 times the largest perfect square that goes into 50 is 25, and 2, so that's 48 times 5 times radical 2. So the answer is going to be radical 2 something. What is 48 times 5? Use a calculator. 48 times 5 is 240. Okay? I believe there's something else.